For those who don't know me, I'm Steev Klimaszewski. My email address, which is the best way to get a hold of me, it's steve@callie.org. Do pay attention to the way Steev is spelled. We do not have an alias set up. So if it does not go to the correct email, I do not get it. I'm not ignoring you. I just didn't get it. My Twitter handle is Steev Dave. I don't pay close attention to Twitter. I'm not going to lie. I have it mostly just to have it. I do reply here and there, but it's not something that I delve in heavily. In most places, I can be found as either Steev and Steev Dave. And as somebody asked, in my spare time, because working full time on the Callie distribution isn't enough, I also am a Gen 2 Linux developer in my spare time. So in terms of what I do at Callie, I'm the Callie ARM maintainer. We release around 20 images that support 26 different machines. And that's the ones that we actually put out that you can download. Overall, we support about 40 different machines, but some of them you're going to have to build yourself using our build scripts. And I probably should have put a link, but that's not here or there. I'm also the Callie Docker maintainer, and I'm the Callie WSL maintainer. We're a small team, so everyone wears different hats. And what is Callie? Callie is the world's most popular penetration testing distribution. The first release was March 13th, 2013, which actually means Friday is our 7th birthday. We are the successor to, it was previously called Backtrack. And so we switched around the way we did it, and now we're based on Debian testing. We would cut a release of Ubuntu, whatever was latest when we decided to do it. Now we have fully automated builds of packages, testing, updates are daily almost. They usually are daily, but almost. And we're based on Debian testing, so all of the Debian testing comes in, so we're much more bleeding edge. We support AMD 64, i386, ARM64, ARMHF, and ARML. And for those who don't know, like ARML would be like the Raspberry Pi Zero or the Raspberry Pi, the original one. ARMHF and ARM64 would be like the Raspberry Pi 2, 3, or 4. And ARM64 is the Raspberry Pi 2 as long as it's version 1.2 or higher. And then, of course, you can run us either as a live image, which is like a live USB, a live DVD. You can install it, or of course, you can run it as a VM. And as I previously mentioned, everyone wears multiple hats on the team. And now Callie on WSL. We first released it when we heard about it on the 5th of March, 2018 into the Windows, the Microsoft Store. We're available for both 64-bit and ARM 64-bit. And one of the main reasons we like it is that it uses less resources than a traditional VM does. Not everybody has a super powerful Windows machine, so they can't run multiple VMs. So this is a nice way for them to be introduced to. We recommend WSL2. It does require being on the Insider slow ring, at least right now. The file system access, much faster. In our testing, we've seen up to 20% faster, which can be very helpful for some of the things that we do. You have access to raw sockets. A lot of our tools, we do a lot of networking testing. So a lot of the tools use raw sockets. And so because of having access to the raw sockets, you just have access to a lot more tools. The downsides, especially WSL1, no raw sockets. That cuts out a lot of the tools. The file system access is often a lot slower. You typically have to add exceptions to your antivirus software. We do have packages that do have things like exploits and various other things of that nature that are they are malicious, or I should say they can be used maliciously. So antivirus rightly blocks it, so you do typically have to add exceptions. And you don't have any type of external hardware access. We do a lot of things like wireless testing. you need access to a wireless card. So, excuse me, without access to that hardware, it doesn't help. So in WSL2, some packages do still get blocked by antivirus. It's not as much, and you don't have access to the external hardware. So I'm going to go through a demo here, and what we've come up with this scenario is I'm excuse me, I'm playing the role of an attacker, and I've connected to this random Windows machine. I've fished the logins or whatever. I'm just a normal user, but one thing that I noticed, excuse me, one thing that I noticed when I connected, if launch, give it a minute, and I'm going to actually do some things here to, just for the demo purposes, I've increased the font size, so hopefully people can read it. You can see I'm just a normal user. So while connected, we noticed Windows Subsystem for Linux is installed. One of the things, WSL is typically used by a developer. Developer systems typically will have maybe some security lapses. And so what we're going to do is we're going to walk through and see if we can somehow take advantage of that. And so the first thing we're going to do, you can either do it through sorry, I call it the Windows Store all the time, the Microsoft Store. Just for speed's sake, I'm going to go ahead and install just through, we've copied the file to somewhere on the machine, which you can also do, assuming you know you are an attacker. But you can also do it through certutil, so you could be hosting it on some website somewhere and pull it in through certutil. And while this is going, it's going to take a little bit. So I'm going to kind of give you the background of the ideas here. We're going to basically install Callie, and then we're going to step through using one of the tools available on it. We'll just go ahead and set up Callie. One of the tools available on it, it's called Metasploit Framework. It's one of the most, if not the most popular penetration testing packages out there. It is bundled with an absolute ton of helpful utilities and tricks that people can do. And what we're going to do is we're basically going to use Metasploit to enumerate all the information about this host. We're going to see what we can find out. We'll just create a demo user because why not? The first thing we want to do, so a typical Callie install in WSL does not have anything installed. We keep that just to keep size down. So we're just going to update to the repos. Luckily for you guys, I have, as a developer, I actually have a local mirror, so it's sitting right there. And we're just going to install Metasploit Framework. And this is actually going to take it a little bit. So assuming the demo god's smiling on me today, we're going to enumerate information about the Windows machine. We're going to see if we can happen to find out any type of antivirus exceptions, anything about the machine that can help us. And typically, you know, there's certain things that I know about a Windows machine, and we kind of you want to know your target, so you should have familiarity. And we're just going to basically show how Callie can be used. Because one of the big things, a lot of people are, oh, you know, Callie, it can't be that useful because you're using Windows. And I'm hoping by the end of this demo, people will say, okay, so maybe we need to rethink that thought process. Excuse me. And I just have to look over to the side because of my instructions being over there. This process takes a bit, so this is actually taking longer. I used an older Apex for this. It doesn't actually matter because as soon as I run this update here, that as you're seeing, it's pulling all of the latest packages in, but the big one being Metasploit. And so we're going to basically use what we call a web handler. And this basically will create a web service in memory. That way nothing is written to disk, so we run less chance of getting caught by the antivirus on the machine as soon as it all finishes, which takes some time. And I do apologize for the silence. I wasn't expecting.
Oh, you're fine. You're fine, Steev. So I've played with Metasploit before. It seems to download. It seems to be one package that then contains like hundreds of tiny packages and exploits inside that you then call with like a scripting language.
Yes. So it's built on Ruby, Metasploit. So
Okay.
the kernel itself is to show off the power of Callie, but just because of time's sake, we're using Metasploit because a lot of it is pre-built. A lot of people contribute to Metasploit, and they basically, it's all written in Ruby. It's probably the biggest Ruby package ever that people actively developed. There are releases, I don't want to say every day, but just about every day there's a new release. I would say at a minimum, it's once a week. But as new exploits get added, as new workarounds get added, and it will actually, I'll point it out once I launch it here in a second. And I'm going to close the terminal in a second, just because one of the things when you install a new WSL instance, at least the version of the terminal I have, it doesn't show up. So I'm just going to close this real quick and relaunch it, just because I want to have it just available in my quick dropdown.
Right.
So you can see now Callie Linux is installed.
Great.
And while I'm doing this graphically, you can do this entirely remotely. And of course, I don't have it set up. The first thing I'm going to do is become root, and that's just because a lot of this stuff is just easier to do. So, can't type today. MSF console is how you launch it. It's going to throw a warning here. And it's going to say that there's no database available. So Metasploit can use a database. We're not in for this demo, but it is helpful. And like I said, I'm not using it for the demo, but you can start the database in WSL. It's not a WSL limitation. It's just we're not doing it. So as you can see, like it reports every time you launch, it reports exactly what it has. So you can see there's 558 payloads, there's encoders. I'm not going to get into what all of those are and what they do, but I will talk a little bit about it as I'm going through this. And some of the output's going to be a little bit harder to read, just like I set up Windows Terminal to increase the font size. So the first thing we're going to do is we're going to start that web delivery handler like I talked about. So, and it does support tab completion mostly, but not everywhere. So the first thing we're going to do, this is our exploit. We're going to create a web delivery one, and we actually just type, it's going to yell at me. It's actually options. We can see when you set this up, you can go through and you can see there are required settings, yes and no. This is one of the important parts because we're attacking Windows. It's show targets. So our targets, it defaults to Python, but we actually want to do PowerShell. So we're just going to set our target to 2. And then we're going to set our payload to be Windows x64, which is 64-bit. And we're just going to use a Metasploit reverse TCP shell. And then we have to set our L host, which is our listening host. Typically, you give it an IP address. We're just going to tell it to use Ethernet 0, and you see it automatically set it to Ethernet 0's IP address. And then we just set the listening port, so what port to listen on. It has to be valid, but you can set it to whatever. You do need to be root if you're using a low-level port, and so that's why we're doing that. And we're just going to do options, and you can see the things previously are now set. So we're going to do a process. It's listening on the IP address, and it's PowerShell. And so now we type run. And what this gives us is the server is now started, and it tells us to run this command. So what we're going to do is we're going to go ahead and copy it, because I am not going to type that out. I'm sorry. I know people want to see that, but I'm not that good. And so we're going to actually run this from within inside WSL, and there's a reason for that. And we're going to call it from the full path to PowerShell, which resides in System 2, Windows PowerShell, version 1.0, and if my paste will work here. So we've run it, and now if we come back here, we should. So it's delivering our payload, and we now have a session. So at this point, we've now connected to, and typically it would be a remote machine, but now what we're going to do is we're going to enumerate what's available on the system itself. So we're going to use, it's called post, because it's basically you connected, so now we want to do some Windows information. We're going to gather, and if I actually hit tab, you can see with tab completion, it's really interesting. It kind of has a bit of a bash shell, but it's not full bash and it's not full Ruby. So I'm not going to show all 121 possibilities. We're just going to tell it to services. And we just do options again. So what we're going to do, so you can set the type, so you can say only manual services, only disabled services, auto all. The session is required. So notice here it says Meterpreter session opened 1, or session 1 opened. You work with sessions in Metasploit, so you can have multiple sessions run. So you want to always set the session to be, the one that you're connected to. So I'm going to run it first. I'm just going to set session 1, and then we're just going to run it. And so what this is going to do is this is going to tell us all of the services that are currently running. I already know the service that I'm looking for. And unfortunately, like I said, because of the size of the font, it's really hard to find. But we're trying to look for some kind of a service that we can abuse. And one common one, and you can see a root file is stored. So all of this information gets stored to a text file that you can then either take off to your local machine or do something with. So if we do options again, what I'm going to do here is I'm going to set the path. It's not really a path, but we're going to look for the word update. We're going to see, we're going to run it again, and we're going to look for any services that have update in their path. I'm not going to get into the deep dive of this, but I'm going to explain just very briefly. Hopefully people are familiar. If not, we'll figure it out. So you see we have a new service credential. Update service runs as local system. So we have update service. It's manually started, and it's here. And as you notice, the startup is not quoted. So that's what we call an unquoted service path. So we're going to take advantage of that in order to basically try and elevate our privileges. Because we're on a developer's machine, we're going to check one other thing real quick. We're going to gather, host Windows gather. Let's just see, maybe we got lucky. Let's just do options again. So once again, we have to set the session to 1. You can see that it will, so it'll check for exclusions in Defender, Windows Essential, and semantic endpoint security. So we'll go ahead and run this. And lucky for us, so apparently this developer is working on some type of an update service, and apparently Windows Defender keeps catching it, so they've added that path to be excluded from getting scanned. So we can take advantage of that. That means if we write to either of these paths, Windows Defender will not scan that binary for us. So we're going to go ahead and open up another handler. So we're going to use exploit multi-handler, and we're just going to set our payload to be Windows x64 interpreter reverse TCP. So we're going to do another reverse TCP shell. Once again, we set our L host to F0. We set our L port to, you can't use the same port because the other one's still listening. So we show our options here. And we just want a wildcard target, that's fine. And then we'll go ahead and just run this. So this is basically a reverse shell that's listening. We're going to go ahead and now we're going to generate that binary that I mentioned. We're going to use another part of the Metasploit Framework. It's called MSF Venom. This lets us basically, you can use it for a number of things. In this thing, we're going to use basically the same setup as our listener. Reverse TCP. We're going to tell it to output to that directory. And we're going to call it update.exe. If you remember, I said we're going to be trying to abuse the unquoted service path. So it'll try, because it says update space service, it'll try update.exe before it tries update space service.exe. So we're going to see if we can do that. And we just set the type, the file type is an executable. The architecture is 64-bit. And then the same thing, our L port, we want to set it to the same one as our others, as our listener that we created over in our Metasploit window. And we'll just set the L host to F0 again. And if I type this all correctly, should build us a binary. No. It's Windows 86. I probably misspelled interpreter. That is the hardest word for me to type. But anyway, so before I run this, so you can see we've saved this file. Something about this. So when I start this service, which I'm about to do, I only have about 10 seconds to actually migrate away from running that malicious executable and actually migrate to a different service. Otherwise, the antivirus will catch us. So we're going to go ahead and tell it to start that update service. And you can see we've got it. So we're going to really quickly grep for DWM. And now we're going to migrate to 644. And I just do DWM. It's just a thing. And you can see we get UID. Get UID. We are currently the system user. Oh, and by the way, so you can also do sysinfo here. So you can see we're running Windows 10 build 19.041. And now, just as an example of something, let's go ahead and background this. So notice once again, so we're on session 2 now. So let's go ahead and do a smart hash dump. And there's not really any. So you can actually tell it to try to get system. We've already got that, so we're not going to. We're just going to go ahead and set our session to 2 because that's the session we want to run it. And now we run it, and what this is doing is this is actually giving us, if it works, it'll give us our password hashes that we can actually just go ahead and pass off to John the Ripper. Or we can do we just run this and right. And so if you don't set an option here, it'll yell at you. So we set our session to 2, run it, and the same thing as before. The difference being that this one is in the John the Ripper format already, and it saved it to that file. Conclusion. WSL2, it's very capable for our need. And we think it would be even better if we could get that Wi-Fi device access. And that's if you have questions, you can feel free to email me, steve@callie.org, if you don't want to ask publicly. Or if there's any questions now, that's fine as well.
Well, that was really interesting, really dense, a lot of questions that came up. People might want to go back and watch that. Are we okay to repost this one later?
Yeah, absolutely. So
okay, so we will be. Yeah.
Just a huge shout out. So Callie, also, this is a question we get a lot. Callie is fully funded by Offensive Security, the makers of the OSCP, the penetration testing with Callie course, and a bunch of other courses. They pay our salaries. They have a bunch of absolutely amazing people. I basically went to the Box Dev team and said, hey, I'm giving a demonstration, Callie, on WSL. This is what I want to do. This is what I want to show. This is my time limit. And this is what they came back to me with. So seriously, the amount of help and development time that they put into this, so I could focus on the actual portion of giving the presentation, has been hugely helpful. So I just want to say thank you to them for that. But because it was developed specifically for this course, for this presentation, yeah, you can fully post it. There's nothing, and just for the record, just so people know, demos use password is demo, and the admin password is actually endpoint. You're not going to get anything. This, by the way, this was all done in a virtual machine. So on top of running Callie, excuse me, in WSL, we were doing it on a virtual machine. So yeah.
Right. Yep.
And questions.
Let's see. Let me check the Q&A to see if anything came up that would be specific to you. The main question was, would this be available later? Because I think people want to go back and follow along with you. But that was fantastic.
Bart asked Wi-Fi access WSL2. Unfortunately, not yet. I really, really wish I did. I love, in my personal life, I absolutely love playing with software-defined radio, which would be another cool thing to have access to. Which, I mean, you can do it in Windows anyways, but some of the tools in Linux are a lot more fun to play with. But having access to Wi-Fi, software-defined radio, and all of the Linux tools that come along with it would be a massive help. I don't know. We were hoping to talk to the WSL team while we were in Washington for WSL Conf. Obviously, that didn't happen. But hopefully everyone's staying safe. So, yeah.
Well, one thing interesting to note is that while Wi-Fi and direct hardware access isn't an option on WSL, there is a serial connection. And we have seen some projects that used the serial connection to do software-defined radio type projects, amateur ham radio type work. So some of that's an option. Of course, there's not a lot of throughput through RS-232,
Exactly.
but it's workable. So if you really dedicated, um, you can connect to your Raspberry Pi or something like that. I really appreciate it, Steve. Thank you so much. And we appreciate Callie and being a part of the ecosystem. And we don't normally recommend disabling Windows Defender because actually Windows Defender is really good at picking up all kinds of stuff, even inside WSL. But for Metasploit, you pretty much have to. So that's what a VM is good for.
Actually, if you want, I can actually show. Let me actually, if you don't mind, um, let me head and if we have time, I can actually generate a new one real quick here.
Yeah, we have a couple minutes before Simon from Docker. So yeah, go for it.
I just want to. I just need to find it in my notes. All right. Exploit multi. I'm just going to basically show you Windows, if I can type, 64, interpreter, reverse TCP, set all hosts at 0, 3G7, and we'll go ahead and run it. So if I actually start this service, so we can actually just do PS, and you can see, but if I actually just wait a minute here, we should. It did in my testing. Come on. So once this fails, I think it's going to fail to start. Okay. I don't know why it didn't pop up. If you don't do it fast enough, the reason why it's dying is Defender does actually catch it. So you do have to be pretty quick. And there are ways around that as well. I didn't show it just because I wanted to show a little extra. But it's definitely, don't think that, oh, I just did all of this stuff and Defender didn't catch any of it. Defender will catch it. I was just typing faster than Windows was able to keep up. Yeah, Windows was not able to keep up with what I was doing.
So, gotcha. Yeah, I've even seen Windows Defender pick up compromised node packages with Bitcoin miners in them. So it's pretty compelling. And I put the link to the website, the post about software-defined radio with WSL in the chat for others who might be interested. Yeah. Well, very cool. I think we are now going to transition to Simon Fairquell at Docker. So thank you, Steve, and we'll catch up with you later.